All right, everybody, good morning. We're going to go over Unit 8 for our semester review. So starting us off, we're multiplying. So if I see something like this, I'm always going to factor first to see if I can get anything to reduce down. So when I look at the top expression here, x squared plus 3x, looks like I can take an x out that's common. So when I take that x away, you're left with that. And in the denominator, x squared minus 25, that's a difference of squares. So we take the square root, getting us x plus 5 and x minus 5. And we're going to multiply by, well, x plus 5 cannot be factored any further, so we can just leave that alone. And likewise with the x plus 3. All right, so now we look for things to reduce. When I'm multiplying, I need to have the same thing on the numerator and the denominator in order to reduce down. So I see I've got an x plus 3 on top and bottom, and I have an x plus 5 on top and bottom. So all that leaves us with in the numerator is x, and in the denominator, x minus 5. This cannot be reduced any further, so that's our most simplified form. All right, the next problem here is division. So same thing, I see this, I'm going to factor. So when I look at the numerator of this first problem, I see that that's a trinomial that we can use our shortcut with. So factors of 18 that can get me to 7. That would be negative 9 and positive 2. And on the bottom is another difference of squares. So we have x plus 7, square root of 49, and x minus 7. But when we divide, remember we actually have to change that to multiplication and then switch the second fraction. So I'm going to change that to multiplication, and I'm going to switch our numerator and denominator. And now that we're all factored out, we can see what can reduce. So x plus 2 can reduce, x minus 7 can reduce, and that just leaves us with x minus 9 in the numerator and x plus 7 in the denominator. And that can also not be reduced, so that would be our most simplified form. Make sure you guys are trying these out before you watch me work them out. All right, addition. So addition, we need to have the same common denominator. So I see I've got this factor of x plus 2. First thing we're going to do is we're going to factor this and see if we can get a common denominator here. So I can use my shortcut. I want a factor of 10 that's going to get me to a negative 3. It'll be negative 5 and positive 2. All right, so now when I look and I compare these two fractions, I see that they both have an x plus 2, and then this one has an x minus 5 in the denominator. So really all we have to do is multiply our x minus 5 as well to top and bottom, and that gives us a common denominator. So now what I'm going to do is I'm going to go ahead and move forward with this step. I'm going to multiply this out. So x times x is x squared. X times negative 6 is negative 6x. Negative 5 times x is negative 5x. And then negative 5 times negative 6, positive 30. Plus our x squared minus 3x minus 9. And we all have the same denominator. So we're already in one fraction here. Okay. All that leaves for us at this point, you guys, is to combine like terms in the numerator. So when I look at our like terms, there are quite a few that can be put together here. X squared, looks like we got another x squared right there. So now we're going to be left with 2x squared in the numerator. I can already jump to the denominator here and make sure I don't forget that at the end, because that denominator is not going to change. All right, next we're going to look at our x's. So we've got negative 6x, negative 5x, so that gets us negative 11. And then one more, negative 3. So negative 11 minus 3 more is negative 14x. And then our constants, 30 minus 9 is a positive 21. All right, now that all of our like terms are combined up here and then the denominators are factored out, we can't reduce, and so we're good. Okay, number 16 is subtraction. So we're going to handle that exactly just like we did with the addition problem. But you'll notice that these already share a common factor. So neither one of these fractions need an additional factor to the numerator and the denominator. So we're already at that second step where we can just combine like terms. So I know that my denominator is going to be x plus 8, and we're going to go ahead and combine some like terms up here. So x squared, there is no other x squared. Okay, so that comes down with us. (4x) can combine with minus a negative x. So 4x minus negative x, which is going to turn into 4x plus 1x. So there's 5x. And then negative 1 minus 3 is going to bring us to a negative 4. So don't forget that minus sign sometimes is going to switch up your signs. Well, at this point, you guys, there's nothing else that we can do to reduce, so we can leave that right there. That one's a little easier when that denominator is already common. Okay, solve and state any extraneous values. Well, I like to start with that, just to know what I shouldn't have at the end. So when I look at x plus 7, I can set that equal to 0, and I know, remember, extraneous values in this situation are found when our denominator is going to be equal to 0. So I know that if I plugged in a negative 7 right here, because if I solved x plus 7 equals 0, I would get negative 7. I know that our x can't be a negative 7. Okay, that I already know. Now we can factor this really quick, just to make sure that there's nothing else that we're missing for our extraneous. So we've got x squared minus 2 plus 7 gets us our plus 5 in the middle, and then gets 7 times the negative 2 gets us our negative 14. All right, so there's our x plus 7 factor again. We're adding in another number that x cannot be, so that's going to be our positive 2 right here. All right, I'm going to erase that. So I like to start off a problem just by knowing, all right, now I can just solve as normal, and if I get either one of those answers at the end, I know it's extraneous. Okay, I see a fraction here equal to another fraction. Immediately, because of that equal sign and the two fractions, I'm going to cross multiply. And with the 1's on top, that makes it really nice and easy because I know x plus 7 times 1 is still going to be x plus 7. And I know that x squared plus 5x minus 14 times 1 doesn't change it, still x squared plus 5x minus 14. Okay, so now that I have this problem, we're going to solve. If I'm solving a problem with that x squared, I'm 90% sure I'm going to have to set everything equal to 0, factor, and solve. We might have to use a quadratic, but at this point, we're going to go forward with that move. So we're going to subtract x, and we're going to subtract 7. So now we have 0 equals x squared plus 4x minus 21. All right, so now that we're here, we're going to go ahead and factor. So we're going to see if that factoring works out. We can use our shortcut. Factors of 21, that can get me to 4. So that would be 7 and 3, specifically positive 7, negative 3 to get us to that positive 4x. And then remember at this point, you guys, we just set those two equal to 0, and we've got a one-step equation in front of us. So we know that x is equal to negative 7 and x is equal to a positive 3. So I see an issue. At the very beginning, we identified what our extraneous solutions were, and we saw that x equals negative 7 could not be a solution. That is extraneous. But x equals 3 is fine. All right, to number 18, solve and state any extraneous values, if any. Okay, so we've got this 1/2 power. There's nothing else out here that we can get rid of, so we're going to go ahead and address the power. So if I flip the fraction, I get a second power, but then I have to also do that to the other side. So now I have 9x minus 18 is equal to x squared. And we're going to handle it just like we did the last one. We're going to move everything over to the x squared side and set it equal to 0, factor, and solve. All right, so we're going to subtract 9x, and we're going to add 18. None of those can be put together, so we've got 0 is equal to x squared minus 9x plus 18. And then let's factor. So again, I see a shortcut with the x squared up front. There is a is equal to 1, so we can do that shortcut. So I need a factor of 18 that can get me to 9, and factors of 18 that can get me to 9 are going to be 6 and 3. Well, we need to get to a negative 9. The only way to do that is negative 6 and negative 3. And luckily that works perfectly because a negative times a negative gets us the positive we need as well. So then we know x is equal to 6 and x is equal to 3. We would normally stop, but now we've got to look at extraneous values. So we're going to plug those back in. So we're checking our work over here. So if I plug a 6 in, 9 times 6 is 54. And then 54 minus 18 is 36. So really that ends up with 36 to the 1/2 power, which is equivalent to taking the square root. Remember guys, this is us plugging in 6 right here. So that has to equal 6. So square root of 36 is indeed 6. That works. All right, now let's handle the same thing with our 3. If I plug a 3 into 9, I get 27. 27 minus 18 is 9. So right now we're at 9 to the 1/2 power has to equal 3. And square root of 9 is 3. Fantastic. So both of those actually work. And then we can move forward. So no extraneous solutions in that one from what we solved. All right, number 19, solve and state the extraneous values, same as before. There's nothing outside this radical I need to address, so I'm going to go ahead and just square it to get rid of that square root. So now I'm going to have x squared is equal to 6x plus 16. Set everything equal to 0, so we're going to switch signs and move things over. So minus 6x minus 16 equal to 0. And then we'll factor with our shortcut. So factors of 16 that are going to get me to a negative 6. That's going to be a negative 8 and positive 2. All right, still equal to 0. And as we solve, remember this is switching our signs here because we're just setting it equal to 0 and solving a one-step equation. So these are the two values that we have. We're going to now plug them in and check our work, make sure there are no extraneous solutions. When I take 8 and plug that in, 8 is equal to the square root of 6 times 8. 6 and 8 went on a date, now they're 48. Plus 16, let's see, 64. And 8 is equal to the square root of 64. That is true because the square root of 64 is 8. And then negative 2. So if I plug in a negative 2 is equal to the square root of anything at this point, you guys. And this is where we talk about stopping because I'm never going to be able to take the square root of something and get a negative number. So immediately I know that this is going to be extraneous, but we can go ahead and plug and chug just for kicks. So 6 times a negative 2 is negative 12 plus 16, so that's positive 4. Well, the square root of 4 is going to be a positive 2, not negative 2. So here's our extraneous. So we would not use that solution. Okay, this one's different because it has this plus 3 out here. So we've got to undo that by subtracting 3. We're not dividing here or else that 3 would be completely linked to our square root. Okay, so since that plus sign is there, we're going to subtract. So now we're left with the third root of x plus 2 is equal to 2. In order to undo the third root, we need to put everything to the third power, just like a square root is undone with a square. So now we have x plus 2 is equal to 8, not 6. 2 to the third power is 2 times 2 times 2, which is 8. And then subtract 2, x is equal to 6 here. So now let's go ahead and plug that in, make sure that works. Perfect handwriting. 3 times the cubed root of 6 plus 2 instead of the x is equal to 5. Forgot that little plus sign. All right, So 6 plus 2 is 8. The cubed root of 8 is 2. And 3 plus 2 is indeed 5. All right, so that one does work out just fine. All right, on number 21, we're talking about those rational equations here with vertical asymptotes and the horizontal asymptotes. So remember, the vertical asymptote's always found from our denominator. So I can look at this x plus 3 and know that my vertical is going to be at x equals a negative 3. The horizontal is from those 3 rules that all compare the very first exponent. Well, in this case, we have an x on top and bottom, so that means that we take the ratio of the coefficients since the largest exponent is the same. So we actually know that this is going to be 5 over 1, or 5. And our domain in a rational equation always goes on forever, but we take out the vertical asymptote and the holes if there are any. So our domain is going to be all real numbers except x cannot equal negative 3. We don't include the horizontal because that's not an x value, and domains are specifically for x values. Okay, and last problem here. Which of the following values of x is undefined? Okay, so all that means is we just need to look at the denominator and figure out which values of x we can't have. Okay, so what we're going to do is we're going to take x squared minus 12x plus 35. We are going to set it equal to 0, factor it, and solve that out to see which values of x we cannot plug in there. All right, so I can use my shortcut. Factors of 35 that get me to a negative 12, that's going to be 5 and 7. They both have to be negative to add up to a negative 12 and multiply to a positive number. And then we do our one-step equation here and add 5 and add 7. So these would be the 2 x values that we cannot plug into the denominator, making those values of x undefined. All right, good luck, guys, as you're working through the semester, and let's get mathy.